So, hello student, welcome back, and today we are going to do revision for Form 5 Science. So as usual, we are going to do some exercise rather than just I'm talking and the student are listening, which is I think it won't be that effective. And the most effective thing is students do by themselves first. So you can always pause. I always will ask you to pause the video, and then you try to think and do before we explain the answer, so that you can think in your mind first. Okay, let's look at this question. A common question in question number 1, subjective. As you can see, usually if you see the format, it always tend to ask question regarding variable. What is the variable of this experiment? What is the hypothesis? What is the inference? And for this first question, sometimes it's easy, sometimes it's very hard, because they can take any experiment. It can be a very difficult experiment, it can be a very easy experiment. So let's read this question. Number 1, a student conducted an experiment. I like to take my pen. Where is my pen? Wait, just let me take my pen. Wait, where's my pen? Oh, it's here. My pencil is here. Okay, I like to highlight it. I think students should do that also when you're doing exam. If you just to highlight the key point. A student conducted an experiment to study the effect of deficiency of nutrient. Affect deficiency of nutrient of the growth of the green seed. So you know lah, usually it's deficiency of potassium. You can see there's without phosphorus, potassium, and this is a good culture. We can see from here, good culture, and this one is obviously we know lah, even though it's not given the hypothesis, but we know he want to test the lack of phosphorus. Based on the diagram, one state the observation of the tree.
Root.
The growth of root deteriorate, or maybe you can want to use other word like the growth of root what?
Standard root growth.
Stunted root growth, okay? Stunt root growth, for example. Or maybe you can say the root growth is poor, okay? The root growth is poor, which is make more sense rather than if you say deteriorate. Okay, so rather than the root growth deteriorate, I think it's correct also lah. I think it's correct. Root growth deteriorate. Okay lah.
Same, right?
Deteriorate means it's a process ma. So maybe if you say the deterioration of the root, deteriorate is like starting to spoil, but it doesn't spoil. It's like the growth is slow, or the growth is stunned. Rather than if you say deteriorate means the thing is spoiling, so the teacher can give you wrong, because the thing is not spoiling, it's only like slow growth. Wait, what has happened to my pen? Don't worry, I can undo. Undo. Okay, I don't know why this thing don't want to disappear, but just ignore this scribble. Okay, state 1 hypothesis of this experiment. So what the hypothesis, what is the relationship, and what's the thing that they want to test in this experiment?
Dealing with complete culture solution, growths are healthier.
Are you sure that is the hypothesis? I mean, the hypothesis is the
nutrient, right? Or the nutrient.
Nutrient. What is the hypothesis of this experiment? Now, what is the thing that you want to test? Do you want to test that hypothesis is a relationship? Usually it's a relationship, and it's something that you want to test.
Dealing with phosphorus, culture solution goes better.
I think the better hypothesis, I think you're almost there. I think the better hypothesis will be either you can say that plant seeding needs phosphorus to ensure healthy root growth.
Or root growth.
Or you can say that seeding is stunted in a solution without root growth. Okay, so I just write here, seeding without phosphorus or phosphorus. Seeding without phosphorus, you can straight solution seeding without phosphorus, the growth of the root will the growth of the root is stunted. The growth of root is slow or stunned, or small, up to you. Maybe I put small small. Okay, so again, let me rephrase because actually I terbalik this sentence. Actually it's correct but if you are English, then you shouldn't write this. You should write something like the growth of the root is more when the seeding is without phosphorus solution. So this one I think this one is English You should always start with this one, because this is like passive is active. The growth of the seed is more when the seeding is without phosphorus solution. So this is the hypothesis, because hypothesis is something that we want to test. We don't want to test in this experiment. It's very obvious. We are not testing that the plant need a full culture solution in order to be healthy, which the student mentioned just now. The experiment is very obvious to show that plant need phosphorus to ensure a healthy root. This is something that you want to test. There is a hypothesis I want to test. Plant need phosphorus in order to have a healthy root growth. That's testing. And how you know? How I know? I do this experiment. I show you. I give the data collection. I do the observation. So this is how doctor, professor that do. They don't just talk. They do the experiment. They show it in a science, because this is science. So this is it's a relationship. Hypothesis is a relationship. It shows a good relationship for this experiment. Okay, this is the keyword. But if your keyword don't have phosphorus, then you won't get wrong, because it is very obvious that they want to test the got phosphorus or no, or you can change the positive one. Okay, seeding with phosphorus will have a healthy root growth. When you go to university, there are a few hypotheses. You can either choose the positive or negative, but it's still it's still the same. State one constant variable in this experiment. What is the constant variable?
Constant variable.
Yeah.
Amount of water.
Amount of water. Okay, so maybe I say volume of culture
Volume
solution.
of water. Oh, okay.
Volume of, somehow what is more specific? What is another one? Volume of culture solution. But I don't think this is really that important. What is even more important for the constant variable? The water. The solution is something that we want to change. I think the more better answer, I think but both is correct I think is the type of seeding. I think this one is a type of seeding, which is more, I think, accurate. Why is more accurate? Because if you use one is the cactus seed and one is a kangkong seed, it doesn't really shows anything, because you are using two different plants, and the root is also different for the plant. But because actually this one volume solution, even if I use this one 100%, but this one I give, let's say 50%, I'm assuming they still will have the same growth. I assume I don't know I need to test but the effect is not as much as you compare to the type of seeding. Very good. I think you can understand the question. This one, both is correct. Both is correct. Okay, the next question. D tick correct in the boxes provided. Boxes provided the element which in the same group as phosphorus. So we have boron, nitrogen. So the answer will be nitrogen. What is the chemical name for
micronutrient? So it's nitrogen.
Micronutrient.
Macro. Boron is micronutrient.
Micronutrient. They are talking about periodic table or micro and micro.
Micronutrient and macronutrient.
Oh, not the
periodic table.
Okay, so they are talking about the group in the macro and micro, is it? Or I thought they are talking about the periodic table.
Yeah, it's in the textbook.
Ah, okay. So of course there's a macronutrient and micronutrient for
Yeah.
plant and also for human. Based on this experiment, state the operational definition of complete culture solution. So when you do this experiment, let's say
Yeah.
I am the examiner, you are the student, you are the PhD student. So then you say you do your experiment, you use, then I will ask you a question. I will ask, in your experiment, how do you define complete culture solution? So what are you going to answer? Okay, very good. Okay, you say that it's again, sorry, your answer again.
Complete culture solution is a type of nutrient that helps.
Type of nutrient, okay. That
helps plant to grow healthily.
That helps plant to grow healthily. Okay, so I think okay, it's a culture solution that produce a healthy plant. As long as you got healthy, good, or of a normal growth, a lot of answer it actually shows that you get correct. Okay, of course the book also got other answer. The book answer actually say a complete solution that produce bigger or more leaf. But if you say healthy, also healthy root growth also is correct, because let's say you are the one that doing this experiment, then we ask you what do you mean, because you are saying that you want to have a experiment to test this solution, and you say we want to use culture solution, and in your research paper also you will say what is the operational definition of it's different than the dictionary definition, because dictionary definition will be always the same. Operation definition is more towards this experiment. When you are talking about this experiment, when you are saying that thing, what do you mean about that thing? So you say complete solution is something, when I do this experiment, it is something that will help the plant to have a normal growth. Very good. So yep, then you can pass your PhD. Yeah. But of course no when you will not do this simple one, you will do a very complex experiment, and there are a lot of things they can ask. Of course they won't ask all these simple question. Okay, a student carried out an experiment to study how the temperature of a solvent. So we already know, the question already shows something. The temperature of a solvent affect the rate of dissolving sugar. So which one is the independent variable? Which one is the dependent variable?
What's the variable?
What is variable? Are you kidding? Wait, independent and dependent variable, bro.
I don't use that. I use manipulated and responding.
Oh yeah. Sorry. Okay. Manipulated variable and what responding variable. Yes.
Responding.
Yes.
Okay, so manipulated variable is the temperature of a solvent. Then responding variable is the rate of dissolving of sugar.
Yes. Okay. Manipulated variable is the temperature of solvent. The rate of dissolving sugar is the responding variable. Yeah. Correct. Sometimes another word is IV, independent variable and dependent variable when we do the research. But actually it's the same thing method variable. I think method variable is more towards the science terminology. But usually for research paper they use IV. It's still the same thing. Okay. So this is thing that we want to change. So we always, when we do experiment, we always look at the responding variable. A lot of people think that maybe manipulated variable very important. No, actually manipulated variable is how to say manipulated variable is something that is not your main point for the whole experiment. Your main point is the rate of dissolving sugar.
Yeah.
So sometimes you can have a lot of manipulated variable. Temperature, you can have some more about what I don't know maybe the nutrients, the volume, the size. So sometimes responding variable also we can have a few. But the main topic of your question experiment is always the responding variable. Okay, so 100 gram of fine sugar. Okay, and we have a sugar solution. Of course, solute and a solvent is here. When you mix it, it become a solution after 35 seconds. So of course, we say temperature. So here is 35 seconds. Here is 8 seconds. So of course, hot dissolve thing better. That's why we cook Milo. We do whatever thing you want to put hot water. But I don't know whether the hot water will destroy the vitamin C or not. So anyway, Milo is not that healthy also. So yeah. Okay, based on the experiment diagram 2, state the difference in the rate of dissolving sugar. So what is the answer?
Hot water dissolves faster.
Hot water dissolve faster. Hot water
Dissolves the sugar faster.
dissolve the sugar faster. Okay, hot water dissolve the sugar faster
Then cold water.
than cold water. Yes. Okay, don't just say hot water dissolve faster, then you will get 0 mark. What does it mean by hot water dissolve faster? Dissolve faster about the banana or the sand, or dissolve what? So you make it clear when you answer hot water dissolve the sugar faster. Also, you might not get mark. This one is question mark up to the examiner to give you right. Then the cold water. Then this shows a complete understanding, a complete sentence. Hot water dissolve the sugar faster than cold water. This is what you want to write in your research paper. You don't want to just say hot water dissolve faster. It is so abstract and subjective, making people wondering what are you trying to say. But of course you say the examiner will know, but and you and the examiner will know. You know lah, for example, like you go to court, you go to lawyer, everything need to be black and white. Everything need to state properly, and you are not stating properly, it is so subjective and it could mean many things. That's why some people study law. What inference can be based on table 1? So this is table 1. What inference can be made?
Temperature also. The higher the temperature, the one is hypothesis. Hot water increases the rate of reaction.
Sorry?
Hot water increases the rate of reaction.
Hot water increases the rate of reaction. Hot water increases the rate of reaction for the inference. Let me think for a while. Okay, so the more accurate answer will be the rate of dissolving sugar depend on temperature. Okay, the rate of dissolving the solvent, the sugar, depend on temperature. Okay, so just now you say could be also correct. Could be correct. Because you say what you say already just now?
Now hot water increases the rate of reaction.
Hot water increases the rate of reaction. But that one is also similar to hypothesis, right?
Yeah, that's why.
Yeah, that's why I say it could be right, could be wrong, because it is hypothesis. Hypothesis in this experiment we want to test. So we say that the higher the temperature, the faster the rate of
reaction.
The reaction. And inference is something that you found in throughout the experiment and you haven't tested it yet. So the rate of it depend on the temperature. This one is more specific. The rate of the dissolving sugar depend on the temperature. So this is not the hypothesis. So you can do another experiment to test it, because you are saying it depends on temperature. So if you want to test this, you need maybe you want to do 37 Celsius, 38, 39, 40, 41, 42, interval 5, 6, 7, 8, 5, 10, 15, 20. This is the inference because you haven't tested it yet. You are saying that it depends on the temperature and what is the graph. Is it like sloping? Is it a linear? Is it go up like this, curve up? So it's something that we haven't tested in this experiment. Inference is something that we haven't really tested. Okay, so it's a different thing. State your hypothesis. What is the hypothesis?
The higher the temperature of the water, the faster rate of reaction.
Okay, the higher the temperature, the what?
The faster the rate of reaction.
The faster the rate of reaction. Very good. This hypothesis shows a relationship that we want to test. How we test? We do the experiment to test. We give the data, we give the conclusion, and people there will be no dispute. So this is how we learn science. And it really helps us in our daily life. That's why some people tell me, oh, vaccination is not good. Show me the data. Show me the control group. Show me the participant. How many people die? How many? You cannot just say, oh, vaccine is bad. If you say vaccine is bad, then show it. Show the data. Show the statistic. Cannot just simply say. And if you say vaccine is good, show me it is good. Then you say, okay, out of this 1,000 population, we notice that 99% is not infected by infected by the COVID-19, and if you again the 1,000 people that is unvaccinated, they actually has 20% affected by COVID-19. Something lah, it must be a data. Cannot be just like I want to say something that I like. COVID is not good. It destroy your antibody. Then show me the data. Show me the citation. Everything you need to talk. And also in your essay, in your public speaking, when you give a proper citation, it always bring more weight of what you are going to say. Okay, state the manipulated variable in this experiment.
Temperature of water.
Temperature of water. Okay, temperature of water. State one application regarding the concept. Wow, this one is like research paper. Say one regarding the concept of rate of reaction. One application in industry sector. Application. State one application. Refrigerator. Why?
Yeah, it's cold. The cold temperature slows down the growth of bacteria.
The cold temperature slow down
growth of microorganism.
Growth of microorganism. Wait, let me look at the experiment again. So actually this is not about microorganism. I know it is correct if it's about microorganism, but this is not a microorganism. This is about the reaction rate of reaction. It's more towards chemical rate of reaction. Like that is why what is the operational definition of rate of reaction? We are talking about the chemical reaction rather than the biological growth. So what is the application industry that uses the temperature to either increase or decrease the chemical rate of reaction? So for example, we can say Haber process.
Haber process.
Haber process or contact process. Okay, Haber process or contact process. To produce what? Haber process to produce what?
Ammonia.
Ammonia, correct. Fertilizer. So of course, if you remember back the the diagram, Haber process. What is the temperature thing? So Haber process is to produce ammonia. We can see from Haber process we use nitrogen plus hydrogen, we get nitrogen hydroxide, which is the ammonia that we want. And one of the requirement is, you can see from this picture, it is when they are combining it, they are using 400 and I think this is spelling error, 400 to 450 degree Celsius and 200 atmosphere. So 400 to 450 degree, that don't put too high lah, don't put too high, don't put too low. Yeah, probably because when you put too high, the reaction also will be faster, but when you put too high, it might cause loss to the industry, because you too high, you need more energy to burn. Eventually you are not helping the company to save money, you are wasting the company money. So of course this one other people already do lah, huh? And the atmosphere also is 200 atmosphere, means how much air compress that you want to do when you are making the ammonia. So I think if you stand near the sea, it will be 1 atmosphere. As you go up to a higher mountain, you got lesser atmospheric pressure because you are going up to the mountain. As you go down the hill, it will be higher, and when you go to the ocean, the atmospheric pressure will be even higher, to a point when you go too deep into the ocean, you will just explode and die because the pressure is just too high. So this one makes sense. Okay, so if you don't know, always use Google. I love Google. Google is my teacher, it's also your teacher. Okay, Haber process or contact process, it answer to the question, which is the chemical rate of reaction. Question number 3, diagram 3.1, diagram 3.2, show the apparatus setup of experiment to study the effect of vinegar and ammonia solution. So they're using vinegar and ammonia solution. They use vinegar, usually which is acidic. Alright or not? Vinegar is acidic, right?
Yes.
So you mix with latex. Latex is what?
Rubber.
Rubber. That I think you get it raw from the tree, and after 30 minutes, the thing will become what?
Hardened.
It become hardened. Gumpalan latex. I think this is a translation error. It's supposed to be what? What is the correct word for English? What's the gumpalan in English called what?
I don't know.
Coagulation.
Oh, coagulation.
I don't know if I spell correct or not, but I know it's coagulation. Coagulation. So it will become like a jelly, and of course you can make it jelly even if you don't put the vinegar. What you need to do is you just leave it. You just leave it in the air. Eventually there will be microorganism growing on the latex, and after that the microorganism will produce acid. Then eventually the acid will coagulate the rubber. But this will make it faster.
Yeah.
Sorry?
Yeah, I said the acid will make the latex coagulate.
Yeah. Then after that, how to make it become more liquid? We use
alkali.
We use alkaline such as
ammonia
solution. So we use alkaline such as ammonia solution. We put it inside. After you mix it, and it will become liquid again. Why do we want to do that? Why you want to make it coagulate and then after that make it become liquid? Why you want to do that?
Make it stronger.
Make it stronger. Make it stronger. What is the application of doing this? Okay, but question. Why a person want to coagulate the latex, and after that he want to make it liquid? Just leave it like that lah. Put in a bottle lah. What is the problem, bro?
To make it more elastic.
I think the answer will be for transportation purpose. You want to I think you answer like this because you haven't been to. Have you been to like the ladang getah, like the rubber plantation? And do you see how they harden the thing?
Not really. I just go and cut the tree.
You should see
They
them
collect.
after they cut, they put in the bottle. After that, maybe they just leave it. It will become like a jelly. Then the poop, a jelly come out, and they will put the jelly, a big jelly lah. It's like that. Then they will throw inside a bag, and the bag will be bring to the factory to be processed. So usually I would say for transportation purpose, wouldn't say it make it more elastic or stronger because it's like a jelly. If you use your hand to peel it, eventually it will still break. It's very smelly and it's very nice. When you are free, you should go. I hope some of the students go. Not only we should study. If I got my school student beside the ladang getah, I will bring them go. Then the student can go. Okay, yes. So it's a transportation, and you put back latex to become liquid that you want to process in the factory. A. Write down one observation from the result of the experiment. What is the observation from the result of the experiment? Observation.
Latex solution with ammonia solution does not coagulate.
Again, sorry, I lost you for a while.
Latex solution that has been added with ammonia solution does not coagulate.
Okay. Does not coagulate. COA. Coagulate. Okay, CUAGULATE. Okay, latex solution with ammonia does not coagulate. Latex solution with vinegar, it will coagulate. Okay, so wait, let me put the latex solution with vinegar, it will coagulate. CUAGULATE. Okay, so even though it's just 1 mark, but I just mentioned it clearly so there is no dispute from the reader and the examiner. Okay, I mentioned very clear. Latex solution with ammonia does not coagulate. Latex solution with vinegar, it will coagulate, and it is the observation. Imagine there's an examiner and we want to give a very clear statement about our research and our answer and our presentation. State one inference based on the observation. So what is the inference from this experiment? Alkaline will neutralize the
acid in latex.
Okay. So maybe I use the first one first lah, the acid lah. I say the vinegar which is acidic, which has acidic property will coagulate the latex. Okay, the vinegar which has acidic properties will coagulate the latex. Or you can use also the ammonia which is alkaline will prevent coagulation. But of course you think it might be the same the inference and the hypothesis. But actually it's not the same, because now you are saying like a new hypothesis. You are saying that vinegar is acidic, it has acidic, so it will coagulate. So this is something that inference is something that you haven't tested but you found out in the experiment. That you are mentioning that it is coagulate because it is acidic. So if I want to do another experiment to support this statement, I might want to use maybe not vinegar. I want to try to use lemon. I want to use soap because soap is alkaline. I want to use orange juice because orange juice is acidic, and you can do it. So it's something new. Inference is something that you found out in the experiment and you haven't tested it yet, and you think it makes sense. It makes sense. Okay, but of course the hypothesis is different. What is the hypothesis for this experiment?
Acid will cause coagulation in latex.
Okay, acid will coagulate. I just write coagulate lah.
Coagulate latex.
Acid will COA coagulate
Yeah.
the latex, and then one more. Alkali
Alkali will
will
prevent coagulation.
prevent coagulation of the latex. Anything lah, just okay. If stop me if you have any question. Tick correct in the boxes provided a substance that can make the rubber more elastic. Which one will make the rubber more elastic?
Sulfur.
Sulfur, yes.
Yeah, sulfur.
Sulfur will make it more elastic. So of course there's a chain, or it's a rubber is always a chain, and when you put S sulfur, eventually it change the chain and change of the bond between the chemical, it make it stronger. State the operational definition of acid.
Acid. Acid is a type of substance that will coagulate latex.
Very good. Acid is a substance that will coagulate the latex. Yes, very good. So again, operational definition is what are you talking about when you are doing this experiment. When I am doing this experiment, when I say acid, means acid is something that will, a substance that will coagulate the latex. So very good. But of course, this is not the definition of acid. Acid means it's actually below pH 7. So it depends. Be careful of whether define acid. What is the definition of acid? Or the question asks, what is the operation definition of acid? Which means that what are you defining when you are doing this experiment. So of course, when you are doing experiment, you will have your own hypothesis, your own problem statement, your own variable, and there are few keywords that you want to key in, like the operation definition for acid, operation definition for alkaline. You want to state in your paper so that it brings clear understanding to the reader. Okay, so we're going to take I see you back by 5:35 lah. We take a 10-minute break, okay?
Okay.
Okay, see you. Bye bye.
Okay.